good evening, everyone.
Good evening, ma'am.
Yeah, what study material are you talking about, Parimal?
Madam, symmetry or group theory wala?
No. These materials are like the presentations you are talking about, or
No, ma'am.
the current today's presentation.
नहीं करत तुझे प्रेजेंट नहीं ओवरऑल स्टडी मटेरियल ऑफ दिस सिमेट्री एंड ग्रुप थियरी का.
Oh, those things are already there on the course, right?
Okay.
Yeah, when you are accessing the course, you can download the lecture transcripts and you can download the lectures as well. The presentations are not there, but when you will download the transcripts, they have the screenshots of presentations.
Okay. Because of ma'am, sometimes the video is focusing only on the surface, but they don't show the slide and something. Sometimes
Okay,
it
so
happens.
those slides, there will be a portion. Let me check 1 second. There, it
Okay.
should be there. We call it lecture transcripts, and it contains like whatever sir is speaking, that will
Yeah.
be there with the slides as well.
Oh. In another course, they have provided a PDF of study material.
Okay.
And if a ma'am is there any book for this course?
Their books are there now. Can you see my screen? See these books are already he has mentioned. Like these are books for group theory. He is consulting these Bishop Cotton.
Okay.
If you will search, generally it is not showing here, but since this course is a old course, right? So if you
Okay.
will search, you will get this symmetry in group theory. Oh, this is the other course. If you will go to the old website now, there will be a website. From here you can just go. In this kind of website, you see this panel is there, transcripts. From here you can download.
Okay.
Right here you have to search. See, this one is there, right? Symmetry in group theory.
Mm-hmm.
You can download videos as well, and you can download the transcripts lecture wise.
Okay.
So let me show you one. Suppose lecture 8 I am downloading. So you will get it like this. See, you will have screenshots and whatever sir is speaking throughout the video is written here.
Okay, ma'am.
You will have this time as well and then screenshot of the video. So this is there for all the lectures.
Okay, no problem.
Around 60 lectures are there now, 60 or 66, 68. So it is there for all the lectures. Okay, you just have
Okay,
to go
ma'am.
to the old website of this NPTEL.
Okay, sure, ma'am.
Yeah, okay.
Okay, thank you.
Yeah. And these slides which I am solving this assignment, these you will get from the current website.
Yeah, I have seen it, ma'am.
Yeah.
Okay.
So did you submit this assignment? Week 8?
Yes, ma'am.
Okay.
Yeah.
You got everything correct this time?
No, ma'am.
What mistake you did. This one was very easy. There is nothing new in this assignment. This okay.
Some question are false.
Okay, let's see. So the
Okay.
first question is for the molecules having a center of symmetry, all normal modes are Raman active, all normal modes are IR active, all normal modes are both IR and Raman active, and IR active modes are Raman inactive, or vice versa. So, this question is related to which concept of physical chemistry? Let me use this color. So, there is something called, you must have read, did you forget? Principle of mutual exclusion. You know about this principle?
No, ma'am.
Okay. Okay, so there is this principle in which calls that if a molecule, for example, let's take CO2. This has a center of symmetry, right?
Yes, ma'am.
Where is it?
At carbon atom.
So it has a center of symmetry at this point at carbon atom. So any molecule which has center of symmetry like this, then for that molecule, the modes which are active modes, the modes which we are solving, translational modes, rotational modes, vibrational modes, right?
Yeah.
So the modes which are active in vibration means those modes which give the vibrational spectra, they won't give the Raman spectra. Okay.
Yeah.
So Raman, how you check whether a molecule will be Raman active or not?
And polar and non-polar.
Yeah, there should be change in the polarizability, right?
Yeah.
You're correct. So, and how you check whether the molecule will be active in vibration or not? The dipole moment of that
Yeah.
molecule should
Dipole
change.
moment for IR spectroscopy. Yes, ma'am.
Yes. So this mutual exclusion principle says that there will be for a molecule containing center of symmetry, no normal mode will be both IR and Raman active. Okay. So if one is IR active, that mode will not be Raman active. If it is Raman active, that will not be IR active. Okay. So this is the case.
Okay.
But it doesn't tell like if there is. So it's like if the mode is not IR active. So no, let me put it this way. If a mode is not IR active, then it will be Raman active. This is not assured by principle of mutual exclusion. Did you get this point? What I have written?
Yes, ma'am.
So it is saying that if there is a mode, suppose I have mode tau 1, tau 2, tau 3, okay, and this is IR activity and this is Raman activity, okay. So suppose we have tau 1, which we know is active in IR, okay, it is IR active. Then if this molecule has I already, okay, this is the condition, first case. If the molecule has center of symmetry, then if the normal mode is active in IR, we can definitely rule out that it will be active in Raman as well. So it will never be active in Raman, okay. So this
Okay.
is the only criteria which is assured by this mutual exclusion principle. On next case, if the molecule is active in Raman, we can be assured that it will not be active in IR. We can rule this out. Okay? But
Okay.
there can be modes which are neither active in Raman, this also cross. Then if this is cross, then we cannot know about whether this is active or not active. It can be active also, or it cannot be active also. Okay.
Okay, ma'am.
So if this is a negation, like this is cross, if the molecule is not active in IR, it does not assure that it will be active in Raman. Okay. If it is active in IR, the rule assures that it will not be active in Raman. You got my point?
Yeah.
So there can be normal modes which are neither active in Raman, like cross here as well, cross here as well, nor active in Raman as well. So this is the principle. So many people take it otherwise, that if it is a cross here, it must be active in Raman. No, it is not the case. If it is active in Raman, if this is the first thing you know, you can cross this out. Okay.
Okay.
So, so it is. So how? What is the basis of this rule? So it says that there is a center of symmetry present here. Okay. So let me write the center of symmetry in a molecule containing center of symmetry or a point group containing center of symmetry. IR active modes get transformed according to X, Y, and Z. X, Y, and Z basis set, right? The dipole moment vector. Okay. And the Raman active modes get transformed according to the polarizability. So, like the quadratic terms x, y, y, z, like that. Okay. So, this is the product of two terms, right? If it is product of two one-dimensional bases. So, under this, I will be plus 1, or it will be symmetric with respect to I. Okay, and since this is single basis set, so it will be character under I will be -1, or anti-symmetric, we can say anti-symmetric with respect to I. Okay, so there won't be, there cannot be a case in which the character under I is both +1 and -1. Okay, isn't it? So the
Yes,
character
ma'am.
will be either +1 or -1, or it will be either symmetric or anti-symmetric. So there will not be any overlap between a -1 and +1. So if a mode is active in IR, means the character is -1 or it is anti-symmetric, then it will not be active in Raman. So this is the case. The basis is this center of symmetry character under the center of symmetry operation. But as I told, there can be modes which is neither active in IR nor active in. So those modes are called silent modes, silent normal modes, which are neither active in IR nor active in Raman spectra. Okay, not active in Raman spectroscopy. So for this question, the correct answer will be
D.
what? What you told? I didn't get you.
D. D.
D.
Higher active
Yes.
modes are Raman inactive.
Yes. So the correct answer is this. So for molecule having a center of symmetry, IR active modes are Raman inactive and vice versa. Okay. So this answer is the correct one. I hope you got this one correct. Did you get this one correct in the assignment? Or you got it now? So let's see the second question. It says that the transition that is allowed by X-polarized light in trans-butadiene is, and it has given that the you can refer the character table of C2H. So trans-butadiene is C2H point group. It will be like this, trans-butadiene. No, there is diene. One double bond here, one double bond here. Okay, so this is the molecule, and we can refer to the character table. So here I have given the character table. Let me zoom it a bit. Okay, so now we have to see which transition is allowed, and that has to be allowed by X-polarized light. Okay, X-polarized light means the one-dimensional basis should contain X term. Okay, so let's see from A1U to A1U. Now how do we find this? So if first option is A1U, so we will multiply the characters under each symmetry operation, corresponding characters. So I have A1U. Now from 1 to 1 means singlet to singlet. Okay. Now we know singlet to singlet transitions is allowed, but singlet to triplet or triplet to singlet is forbidden transition. Okay, so we can first see it is singlet to singlet, so it is allowed. Now the character under AU, so this is AU, character is 1 1 -1 and -1. So again the next state is again AU, So we can again write the same characters 1, 1, minus 1, minus 1. Now we have to cross multiply it. Okay, cross multiply means you have to multiply the corresponding characters. So this is E, this is C2, this is I, and this is sigma H. So we have to multiply the characters under E, corresponding characters, and write the value. So 1 multiplied by 1, the multiplication is normal multiplication. Okay, so 1 times 1, it is 1, 1 into 1, it is 1, minus 1 into minus 1 is 1 again, and minus 1 into minus 1 is 1 again. So you see, these characters, it belong to which mode here according to the character table?
AG.
AG. Okay, so this becomes AG, and we can now check whether AG contains the X basis or not. So this is AG, it doesn't contain the X term here. X is only present in BU. Okay, so
Yeah.
this transition A1 U to A1 U, this is not allowed by X polarized light. So this is not the answer. Okay,
Yeah.
so we have to multiply each and check which one the, after cross multiplication we are getting the mode BU. So that will be the allowed transition in this case. So next one is A1 AU singlet, BG singlet. Again, it is singlet to singlet allowed. So AU is 1, 1, minus 1, minus 1. Okay. So this is AU 1, 1, minus 1, minus 1. And BG is this one, second number 1, minus 1, 1, minus 1. So this is 1, minus 1, 1, minus 1. So again, we have to do cross multiplication. Corresponding characters we have to multiply. 1 into 1, 1 into minus 1 is minus 1, minus 1 into 1 is again minus 1, minus 1 into minus 1 is 1. Now this is, now this is BU. So we got 1, minus 1, minus 1, 1. These characters are present in the normal mode BU, and BU contains the X basis. So this transition is the correct transition. It gets, so X is transformed according to the BU mode. So this is the correct answer. Okay. We
Yeah.
can also check the others quickly. So C option is BU singlet, BG singlet. Now, do you know the meaning of U and G here?
Jirad and non-Jirad.
Yeah, that's right. So this is BU. Now after multiplication, what we will get? 1,
1, 1,
1,
minus 1, minus 1.
minus 1, minus 1. Now check whether 1, 1, minus 1 is transforming according to AU. 1, 1, minus 1, minus 1. So AU, and it is containing the polarization, the basis Z. We need X. So this transition would have been allowed if the question was asking Z polarized light. So this
Yeah.
is AU, and it is getting transformed according to this Z basis. Okay. Now D1 also we can check. B triplet G, A singlet G. So this is 1, minus 1, 1, minus 1. A singlet G will be all symmetric. Cross multiplication 1 minus 1 1 minus 1. Now this is again BG. Okay, 1 minus 1 1 minus 1. This is this one. But it doesn't contain any XYZ basis. So this is again not allowed. Okay, doesn't contain XYZ basis sets. Also you can see it is 3 to 1 transitions, triplet to singlet, which is not allowed anyway. It is a forbidden transition. Okay.
Okay.
Okay. So let's see this one. Now this question is the symmetric and asymmetric stretching mode of cis PdCl2 NH3 whole 2 are respectively. Now symmetric and asymmetric. In class we have been taught about which molecule? I think BF3 molecule. So we
Yeah.
derived the vibrational modes of BF3 in the week 7 classes, I think. And then we classified all the in plane vibration, out of plane vibration to each of the normal modes. So same thing now we have to do, but the molecule is this this cisplatin. Okay, so let's write this molecule. Uh, PD. Oh, it's not cisplatin, it's palladium. Okay, Cl NH3 NH3. Okay, so here the point group is C2V. Okay,
Yeah.
this axis is C2 here. Okay, and there is a plane also along this axis, and there is one plane which contains this molecule. Okay, so two plane, one axis, and one identity element. So this is C2V. Now this is the character table I have attached here. Now what first we do to find the normal modes? What is the procedure?
Metric transformation.
No, if you will do with matrix transformation, it will take a long time. What is the shortcut? So we find the number of unshifted atoms.
Yeah.
The last week assignment, what we did? E C2Z sigma V XZ sigma V YZ. So last week's assignment, the whole assignment was this only, no? We had to find the number of unshifted atom, then we will multiply it with the characters of each symmetry operation, then we will get a reducible representation, then we need to find the constituent irreducible representation which is forming that reducible representation. Okay, so
Yeah.
for that we use the great orthogonality theorem formula, and then we get a total irreducible representation. Then we subtract the the translational and the rotational contribution, and we get a tau vibration, which contains all the normal modes under vibration. So that's what we have to do. And now, and in this question additionally we have to find which mode is symmetric and which mode is antisymmetric or asymmetric stretching. So that is the whole question. Okay, so for E, what will be the number of unshifted atoms?
5.
5. So this is 5 for C2Z.
1.
1. What is that atom?
Palladium.
Palladium. Okay. And then sigma V?
3.
3.
Take 1 minute. Sigma will passing through chlorine.
Sigma V, this one is same as
Oh, no, 1, 1, 1, 1,
passing
1,
through
1.
C2, like containing
Yeah,
C2.
1, 1.
So again, this is PT.
1.
And then this is the molecular plane.
Okay, the same 5.
Same 5. So this is sigma YZ and this one is sigma XZ. So this is 5. Okay. Now
Okay.
characters. For E, the character is 3.
3.
Now from where this 3 comes from? Do you know?
XYZ axis, मैम आपने last time भी बताया था ना?
Yes, that
You
is
told me,
correct.
yeah.
Yes, the XYZ for under E, the XYZ does not change at all. So those 3
Yeah.
axes contribute to the character. For
Yeah.
C2Z,
C2 0.
no, it will be -1. For C2Z, what happens? So you can also check from here. C2Z है ना यहाँ. So
Yeah.
we have to add the X, Y, and Z characters. So Z is 1, then X is -1, and Y is -1. So if you will sum this, you will get what? This will cancel out, you will get -1.
Okay, -1.
So the character is for C2Z, the character over here, which will come here, is -1. Okay. Then sigma V,
Sigma V 1, 1, I think.
yes, for both sigma, it is 1 and 1. Okay. And then what we need to do next?
Multiplication.
So multiplication. So let me do it in the next slide. So multiplication will give me the reducible representation. So after multiplying, I will get 5 into 3, 1 minus 1,
15.
1 into 1, 5 into 1. So 15 minus 1, 1,
-1,
5.
1, 5.
Yes. So I'll get 15 minus 1, 1, and 5. Now this is the reducible representation. I have to break it into irreducible components.
Yeah.
So first thing is we need to find out the contribution of each normal mode. So first normal mode is A1, then we'll find for A2, then B1, then B2. Okay, 4 times we have to do.
Okay.
And what is the
Yeah.
order here? We need order for this formula.
4.
Order is 4. So order is sum of these coefficients. Here all the
Yeah.
coefficients are 1. So order is
Yeah.
1 plus 1 plus 1 plus 1. Order is 4. So contribution of A1. Let me put this character table here. Okay. So now A1. 1 by 4 because order is 4. Now, what shall I write here?
Uh, fif- 15
15
into 1.
into 1 into 1 more
Uh,
1. Okay. Remember that we always make it a habit to multiply it with the coefficients, even if the coefficients
yeah,
are
okay,
1.
okay.
Yeah, right here, because in all character tables you won't get the coefficient 1. For example, if it is C3V, you will get 1, 2 and 3. So if you forget to
Yeah,
multiply that, you will get wrong answers.
okay.
So always make it a practice to write 3 numbers here. So one is the
Okay.
reducible, this is the coefficient, this is the character from the character table.
Character.
Okay. So
Okay.
next is minus 1,
Minus 1, 1, 1.
1. Nice. Next one.
1, 1, 1.
Yes.
That's 5, 1, 1.
Okay. So this will be 15. This both will get cancelled out. Minus 1 plus 1. And this is 5.
Yeah.
So it is 20 by 4, which
Okay.
is
Which is
5.
5.
Now, next normal mode is A2. One minus one, one. Then 5, 1, minus 1. So this will be 15 minus 1 minus 1, and this is minus 5. So this will be 8 by 4, which is 2. Next I'm just writing it off. A for B1. This comes to be 12 by 4, which is 3. And the last one is B2. Okay, this will be 20 over 4, which is 5 again. So we got our contributions. So I can write as tau RR will be 5 times A1, 2 times A2, 3B1, and 5B2. Okay. Now
Okay.
what we need to do next? This is the total number of modes. क्या हमें निकालना क्या है?
Normal modes.
Normal modes
Vibration.
for vibration. Okay. This
Yeah.
is the
Yeah.
total number of normal modes. Okay. So इसमें से we need to minus the translational and rotational. Now translation is XYZ. XYZ. So A1, B1, B2. A1, B1, B2. Okay.
Okay.
What will be the rotational modes?
A2, B1, B2.
Yeah, correct. So this will be A2, B1, B2. Now, if you will subtract these two from this total, you will get vibration. Okay. So ऐसा क्यों कर रहे हैं बोलो? What is the basis for doing this? Why we are subtracting these two?
Only we get from the vibrational mode only.
Yes,
So
but
it has all types of mode. So only we
yes.
have we have to
So this is for
subtract the transition
3n.
mode.
3n. 3n means the total number of degrees of freedom which a molecule has is 3 times n. Okay? Why 3 times
Yeah.
n? Because a molecule which has, suppose it has n number of atoms, 1, 2, 3, 4, there are so many atoms, but each atom has x, y and z coordinate to move along. Okay, so this is 3 coordinates and there are n atoms, so each atom can move along any of the coordinate. So for a molecule, the degree of freedom is, total number of degree of freedom is 3n. So this thing which we got is the total number of degrees of freedom, you can say. So from that, now this total number of degrees of freedom consists of translational, rotational and vibrational motions. So to get the vibrational motion, the contribution of vibration, we need to subtract the translational and rotational contribution. Okay, so that's what we are doing. Now after subtracting, we will get 5a1 minus a1, we will get
4A1
4a1 plus
plus
a2,
A2
yes, plus
plus B1.
b1 plus 3b2. So this is the vibrational thing. This is the total number of vibrational modes. कितने modes हैं अभी बोलो? Total number of vibrational modes कितने हैं बोलो?
3, 4, 7, 8, 9.
Yes, 9. So this is all are one dimensional. So 4 into 1 plus 1 into 1 plus 1 into 1 plus 3 into 1. So we have 9 vibrational modes. Now we need to check out of these 9 what is symmetric and what is asymmetric stretch. So okay, now let's draw this molecule again. For symmetric stretch, let's say, symmetric stretch is easy to say. Symmetric stretch means it is symmetric with respect to all the characters. तो कौन सा normal mode होगा? Out of these 4, which mode is symmetric under all the symmetry operations?
A1.
A1, right? So under A1, all the characters are 1. So it is symmetric with respect to all the operations. So symmetric stretch will definitely belong to A1. Okay?
Yes, ma'am.
So इसको हम check भी कर सकते हैं. You can check like we have this molecule. For symmetric stretch, this will stretch equally. All the bonds will stretch equally. Okay. So under E, suppose this is R1, this will be R1, sorry, this will be R2, R3 and R4. So we will get characters E, C2Z, sigma XZ, sigma YZ. Under E it will be 1 always, right?
Yes, ma'am. Yeah.
Now C2Z. So C2 is where? Here. So this is C2. If we'll apply C2, R1 will come here, R3 will go there, but the bonds are equal in length. Now our basis set here is bond lengths. Okay, we need to check the bond lengths if they are changing or not. Okay, stretching
Okay.
means change in the bond length. Okay,
Yes,
so
ma'am.
we need to
Yeah.
check the bond length. So R1 and R3 are equal, R2 and R4 are equal. Okay,
Yeah.
so when you will apply C2, what will happen? This bond will go there, this bond will come here, but the bond lengths are
R1
equal.
become R3.
Yes, but R1 is equals to R3. And here R2 is equals to R4.
Yeah.
So will there be any change in the molecule after applying C2?
No.
No. So the character will be 1
1.
because it is symmetric with respect to C2.
Yes, ma'am.
Yeah. Now in the same way we will apply sigma xz. Sigma xz is simply the plane containing the C2. So a plane like this. Okay. So it will
Yeah.
reflect. R1 will get reflected to R3, R3 will get reflected to R1. But again, the bond lengths are equal because it is a symmetric stretch.
Yes, ma'am.
So here also the character
So
will
it
be
is
1.
1.
And
1.
this one is the molecular plane.
Yeah, the same 1.
Same 1. So molecular plane is like this. A plane which contains this molecule. Okay, like this. So it will be 1 again.
Yes, ma'am.
Okay, so now you from the characters like this also you can deduce that it belongs to A1. Okay,
A1.
so symmetric
Yes, ma'am.
stretch belongs to the A1 normal mode. Next we need to check for asymmetric stretch. So asymmetric stretch is like if this molecule is like this, suppose these are the initial bond lengths. Okay, so this will get, if this is getting stretched more, this will be stretching less. And suppose again this is stretching more, this will be stretched less. So bond lengths will change. So it will become
Yes, ma'am.
something like Vd. This bond length is small, this is small, and this has stretched more like this, and also this has stretched more like this. Okay,
Yeah.
so these bond lengths are different now. This is R1, this is R3, but here R1 is not equal to R3.
Yes, ma'am.
Yes, this is R2, this is R4, but again here R2 is not equal to R4. Okay,
Yes, ma'am.
so when you will apply, this is C2, right here. Oh, I drew the molecule in a rotated manner, so C2 is here now. This is C2. Okay,
Yes, ma'am.
so when you will do C2 operation, this will get flipped.
Yeah.
So character under C2 will become
-1.
-1 because it is not symmetric anymore. Under E it is 1 always. Okay, no change.
Yes.
So after C2, R1 will come this side, R3 will go this side. So the molecule will flip along the Z axis. So it
Yes.
is antisymmetric. Similarly, the sigma V,
-1.
it will be -1. And this is the molecular plane. So this is the
It
plane
becomes 1.
containing the molecule. So it will be 1 because the
1.
reflection is, so you can think of this is top side, this is
Same.
downside. So even after
Yeah.
reflection it will be same.
Same.
So it is 1. Now
Yeah.
we can check what mode is this.
Character development.
Yes, so we got this one, 1 -1 -1 1. Okay,
Yeah.
so
B2.
this is B2 mode. Okay, so asymmetric stretch, it belongs to
B2.
B2 normal mode, right?
Yes, ma'am.
So out of this, so this one is symmetric stretch. So there are four. The one of them is symmetric stretch. The other can be any other motions like bending, twisting, like that. Okay.
Yeah. Okay. Okay.
In plane or out of plane. There can be other modes as well. So four are there. Four will be A1. Out of those four, one is symmetric stretch.
Okay. Yes.
Okay, and out of these three B2, one is asymmetric stretch.
Yeah.
So now we have got the complete answer for this question. So one is A1, one is B2. A1,
Yes,
B2.
ma'am.
This option D. Okay,
Yes, ma'am.
sure. Okay, so the question is clear.
Yeah.
Okay, next one. Next one is an easy one, and this has been done in class. Boron trifluoride. Can you do this now? I will show you, I will tell you the point group is D3H.
D3 is, yeah.
So I will put up the character table also here. For D3H. Okay, so this is the character. Can you solve this and tell me? I'll wait for your answer. The molecule is BF3. I'll start. Now here what we need to do, we just need to find the tau wave part. There is no question about which mode is what. Okay.
3H.
So first find the number of unshifted atom. Okay, under all these E C3, 2 times C3, 3 times C2 dash, sigma H, 2S3, 3 sigma V. If you will get this correctly, other things you will get correct.
Yes, ma'am. What about E? 4.
Okay, this is 4. Next,
1.
1. For C2,
2.
2.
C2 में 2.
Sigma H,
4.
4. Unshifted, yeah, 4.
Yeah.
S3,
1.
1. Very good. Sigma V,
Sigma V 2.
2. This is it. Then you need to multiply it with the characters. Okay.
Yes,
So
ma'am.
character
Yeah.
you will get from here. This is x, y, and this is z. So for under
Yes, ma'am.
E it will be 3. Under C3 it will be 0, -1 + 1, 0. Under C2 it will be -1, sigma h1, S3, so it will be -1, -1, -2, and sigma v is 1 again. Okay. So
Okay.
what we will get after multiplication? 12, 0,
Yeah.
12, 0, -2. So we will get 12, 0, -2, E, 2C3, 3C2 dash. What else? Sigma H is 3 sigma V. Now this is 4, this is -2, this is 2. 4 -2, 2. Okay, this part is done. Next, what we need to do?
Rotational and
Rotational, and first we need to
trans.
find the total. We need to
Yeah.
convert this into irreducible representation का linear combination.
Yeah.
Okay, so we need to
Okay, ma'am.
write tau rr as sum of irreducible representations. Okay,
Okay. Yeah.
not exactly sum, it can be negative also, sum or linear combination, addition or subtraction. Okay, so
Okay.
how to do that?
12 into E.
Yeah, what is the order here?
12. 12 number.
Okay, so first A1, I will put this here. Now you do this. 1/12. Rest of the things you fill and tell me how much it is coming.
12 into 1 into 1.
Okay, you do it and just tell me the final answer. Are you solving it?
Yes, ma'am.
Okay, fine. Take your time. what you need to do is 12 into 1 into 1 plus second term, no need to write because this is 0. So if anything you multiply by 0 goes to 0. Next is minus 2. So, but don't forget the order. So if you are not writing 0 here, you don't, you have to go to the third term. Leave this term. So you can simply tick it off. Okay. Next is minus 2, 3, 1. Okay. And then plus 4 into 1 into 1. Next is minus 2 into 2 into 1. Next is 2 into 3 into 1. Okay. So what is the answer coming?
12. 12 divided by 12.
12 divided
1.
by 12. So it will be 1. Okay. So the contribution for A1 in this tau RR is 1 time. Okay.
Yes, ma'am.
So similarly you can do for others.
Yes, ma'am.
Okay. Try it yourself. Okay. If you will not do it yourself, it will take like a longer time. If you will do it 2-3 times, you will be like practiced and it will be fast. So I'll give you the final answer. So tau 3n, it is the total what we will get is a1 one time, then e dash 3 times, then a2 dash 2 times, then a2 a2 double dash 2 times, a2 dash 1 time, and then e double dash. This is what the total will come out. So we have 6 modes here. 1 2 3 4 5 6. So for e dash we have for this it the contribution will come out to be 0. A2 dash. Okay.
Okay.
So we will get only these 5. Now subtract the translational thing. Translational is e dash and
Yes. A2 double
a2
dash.
double dash. So e dash plus a2 double dash. Then rotational is a2 dash plus e double dash. Now you can get the final answer as the vibrational. It will be a1 dash.
2, yes. A2 double dash.
That's it. These two will get cancelled away.
Yeah.
Yeah.
Yes, ma'am.
So this is the final answer. Total number of vibrational modes. So the question is, the correct option is D.
B.
So this is the correct. Okay. Fine. You
Yes,
solve
ma'am.
this on your own. Okay.
Sure,
And check
sure. Yes.
if you get the same thing or not.
Okay, ma'am.
Okay. Next is for the irreducible representation. This is the same question. It was there in the last I think sixth assignment. Okay. So this is
Okay,
the
ma'am.
same question. Now we need to find the Mulliken symbol for this. So here I have given a table which helps in deciding what will be the Mulliken symbol. Okay. So you need to memorize this, or you will simply get, if you will do this for 2-3 times, you will remember this. So first thing is A or B we need to write. If it is singly degenerate, means it is one dimensional. Can you see this?
Yes, ma'am.
Or shall I zoom it more?
If possible.
Okay. Now can you see this?
Yes, ma'am.
Okay. So first is A or B. The Mulligan symbol will start with the letter A or the letter B based on if it is one dimensional. First of all, how we will check one dimensional? The character under the E should be 1. Okay.
Okay.
So if it is not 1, it means it has other dimensions. So if it is 2, if E equals to 2, the symbol will start with the letter E. If E is equals to 3, the symbol will start with the letter T. Okay. So
Yes, ma'am.
So for E equals to 1, the symbol can be either A or B. Now, when it will be A, the next thing we will check, first is we will check whether E is equals to 1 or 2. So let's say if there is some character table given in which under the symmetry operation E the character is 1. Okay. So now we know the symbol should be either A or B. Now how A will come? So next step is we will check the character under the principal axis. So if it is symmetric with respect to the highest order axis, principal axis, so under principal axis it should be +1. Okay. And if it is +1, we will write the letter as A. If it is principal axis, the character is -1, we will write it as B. Okay.
Okay.
So, so this is, suppose this is E, C4, C2, like this it is given. Here it is 1. Then here it is -1, here it is 1. Okay. If something like this is given, then
Yeah.
step 1, check the character under E. It is
Yeah.
1. Okay.
Yeah.
Now it means the letter I will write will be either
One
A
dimension.
or B. Now A और B में से कौन सा होगा ये हम डिसाइड करेंगे by looking at the principal axis.
Principal axis.
So principal axis will be C4, the highest order
Equal.
axis. So
Yeah.
in this case, in this example, C4.
Next one.
So it is negative,
So it implies
-1. So the symbol will be B. Okay.
B.
So
Yeah.
this whole thing is step 1. Okay. Step 2.
Yeah.
Step 2 is from here, this subscript. Now these two are for higher orders, 2-dimensional, 3-dimensional. But if it is 1-dimensional only, this part we have to do. Then go to these parts. Okay, these parts.
Yeah.
So if it is now under, we will check C2 axis perpendicular to Cn. For example, this one, as I have given C2. This C2 will be perpendicular to this principal axis. So the character under this is 1. So we will write the subscript 1. Subscript means this here, subscript means here we have to write 1. Okay. Here I will write 1. Oops. Okay, I'm not able to
Yes.
write in the slideshow mode. So it will be B1. Okay.
Yeah. Yes,
If
ma'am.
had this C2 been -1, the subscript will be 2. Okay.
Antisymmetric. Okay.
Antisymmetric, yes. And if this C2 is not there, we have to look for sigma V plane.
Okay.
Okay. If C2 is there, then look to C2 first. If C2 is not there, then look for sigma V. Okay. Then check
Yes,
whether it is symmetric with respect to C2 or sigma V or not. If it is symmetric, put the subscript 1. If it is antisymmetric, put the subscript 2. Don't put -1 there. Put the subscript 2. Okay.
yeah,
Next
yeah.
thing. Next step, look to sigma h. So if it is symmetric with respect to sigma h, put prime. If antisymmetric, put double prime. So if the prime here, prime or
Yes, ma'am.
double prime. Okay.
Okay.
If sigma h is not there, no need to put any prime, any dash. Okay.
Okay.
Next, we need to check under inversion center I. If I is there, we will put one G here. If I is not there, we will put U there. So that will be
Muted.
the
Yeah.
total Mulliken symbol. Now, this was the part when it was one dimensional. Okay. The same
Yeah.
thing happens, same procedure we need to follow for two-dimensional thing also, except for the part, this part. Okay. Except for this part.
Yeah.
Okay. So for two-dimensional, let's go back to the, so let's go back to this. So here we have two-dimensional basis. It is a two-dimensional character. Now let's see. So the character under E is 2. Okay. So
Mm.
now I know the Mulliken symbol will start with the letter E. Okay.
E.
Yes.
Yeah.
Next step. Now we don't need to look
Principal.
for this CN. That was only for one dimensional thing.
Okay.
Next step is we will look to for subscript we will look either C2 or sigma V. Okay.
Yeah.
So now we will look to this C2.
C2.
Okay. Now
C2
C2
is
it is
0.
0 means it is symmetric. Okay.
Okay.
Since it is a now +1 -1, it will come only when the basis is one dimensional. So if the basis is multi-dimensional, we will have any positive number. If it is any positive number, that means it is symmetric. If it is a negative number, that means it is antisymmetric. Okay.
Okay.
So that thing is written over here. Can you see this box?
Yes, ma'am.
Chi is equals to +1 or -1 for one dimensional basis only. For multi-dimensional, see, multi-dimensional means the character under E can be 2, 3, 4, 5 or anything. For
Yeah.
multi-dimensional representation, any positive entry is considered to be symmetric and any negative entry is considered to be antisymmetric. Okay.
Yeah. Yeah.
So now you can ask me whether to consider 0 as positive or negative. So 0 will be considered as positive only. Okay.
Okay.
So now this one is positive means symmetric. So for symmetric the subscript is 1. So this is 1. Okay. Next.
Okay.
Sigma h, we need to look, since sigma h is there, we need to look for
Yeah.
sigma h also. If sigma h had not been there, this was the Mulliken symbol, that's it. But now sigma h is here, so we will sigma h, it is symmetric since it is a positive number.
Yeah.
so
Symmetry.
so it is symmetric. Now for symmetric sigma h, we have to put prime. So
Prime.
there will be one prime here. Now next step was to look for inversion center, inverse.
I.
But there is no I here.
No inversion. Yes, ma'am.
Okay. So there is no
Yeah.
I means that's it. This is the Mulligan symbol.
Even. Option C.
Yes. So this is the correct answer. Okay.
Yeah.
So this was for question number 5. Okay. Now question number 6. This is again the same thing. Now you should do this one.
Okay, ma'am.
Now in this we have not been given any molecule, but we have been given the, what is this?
Character
This
table.
is the tau RR. Yes, and character table as well. So tau RR is given. Now we need to reduce, write it as the sum of irreducible representations. So
Yeah.
constituent irreducible representations you need to find out. So first you need to find out A1 is equals to what? A of A2 equals to what? A of E is equals to what? Okay?
Yeah.
Do it and tell me the answer. This is a small one. You can do it quickly.
Yeah. Sure. 1, 1, 3 into 2 into 1, and it is 0. So A1 is equal to 2.
Okay, very good. A of A1 equals to 2. Then do for others.
1 into 6 into 1 into 1, 3 into 2 into 1. And A2 is equal to 2.
Okay, that's also correct.
3, 6, 1, 2, plus 3, 2, minus 1. 1 upon 1. A is equal to 1.
Yes, that's correct. So that's it. This is the answer. So it is tau is equals to 2 times A1 plus 2 times A2 plus 1 time E. Isn't it?
Mm. Yes, ma'am.
So the answer will be D.
Yes, ma'am.
So did you submit this one correctly or not in the assignment?
No, ma'am. It was wrong.
So now you know now how to solve it.
Yes, ma'am.
Yeah. You can practice more questions like this. Okay. For
Sure, ma'am.
exam. Yeah. And what happened to your registration for exam?
They don't reply properly.
Okay, so you could
They
not register.
No, ma'am.
Did
Is
you
there any
try?
chances to register?
Uh, registration date is still open or has it been closed? I don't know.
No, it was closed, ma'am.
It was closed. Okay. Then I don't know whether maybe by mailing them you can tell like I had problem with photograph.
No, 6 time I have mail, email, mm,
Oh,
but
okay.
return response.
Oh no. Are you mailing with to the correct email ID? What email you are mailing? They
No,
generally reply. They're good at replying. They reply fast.
no, they reply, but they deny to register. once they have said that your core side not uh, fetching your course dot do not fetching. Yes, they replied.
Oh, okay. Okay, fine. Maybe it's okay. Uh, you can practice. There will be many questions on group theory, right? You can practice other questions from any other sources. Maybe you can
Sure, ma'am.
practice the gate exam or net exam previous year questions.
Okay, sure, ma'am.
Yeah.
I will
Okay.
try it.
Yeah. And then, so we have this last question, but this question has been repeated, I think, third time in this week's assignment. I have
Yes, ma'am. It
already
is
solved it.
A1.
Yes, it is A1. I have already solved it in week
Yeah.
6, and it was there in week 7 also, and now in week
Yes,
8 as well. So there's no point in solving
yes,
this.
ma'am.
Yeah.
Yeah.
So I think that's it for today. Oh, this
Sure.
is the
Okay,
same
ma'am.
question. Okay.
Okay, thank you, ma'am.
Yes. Okay, so there's one more question. I think you can do this. This is one extra question which I have kept. You can try
Sure.
solving this now.
Identified and medical notation following skills is representation equal to 1. It gives a 10 principal axis CN is 1. That is A1. Then sigma
First will be
A A1
A. Yes. First we need to check E. Always you
one
need to check
dimensional.
one dimensional. So either A or B. Since all the options are A or B, we can guess it. So now next one is we need to look for this CN. CN
Principal
is the
axis.
principal axis.
Yeah.
Symmetric.
Yeah.
So it is
It is A1.
it is A.
Ah,
Not yet one. We did not reach one. Now for
okay.
A for the subscript, we will look to the C2 axis which is perpendicular to the principal axis, which is these. If this C2 is not there, there will be sigma V present. So either look for
Okay.
C2 or look for sigma V. If both are
Okay.
present, then look, the first priority you will give to C2. Okay, you
Okay.
got my point, or shall I repeat?
Well, we have to. Second step is the principal axis now.
Step 1 is the principal axis. Step 1, this principal axis, which will tell whether it is A or B,
Okay.
whether it is letter A or letter B. Okay, this is step 1.
Yeah.
From CN. Okay, step
Okay.
2 is this. Now A
C2.
is there. Now we need to look for, so this is step 2 from the C2 axis, which is perpendicular to principal axis, which is this. So it is
Yeah.
negative,
My,
antisymmetric. So
yeah.
now we will look for
Subscript
subscript.
2.
Subscript will be
2.
2. Okay.
2. Yes, ma'am.
Now step 3. So A2 is there. Now step 3 is sigma H.
Sigma I minus 1. And double prime.
So it is negative, antisymmetric. So it is double prime.
Double prime.
Yeah. Then step 4,
I.
A2G is there. So step 4 from I. Since I is present,
Yes.
so we are looking for I. If I is not there, then up to this. So whatever things are not there, if only three things are there, the symbol will be up to A2. If sigma h
Okay.
is there, we will look for sigma h as well. If I is there, now we have to look for character under I as well. So it is negative, means antisymmetric. So for
Yes,
antisymmetric,
right.
what we write?
U.
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 So there will be one more term in the subscript, which is U. So the total character is A
A
to
to U
U
double
double
prime.
prime. So it is B option.
Sure.
Okay. So that's it for today.
Sure.
These many questions only.
No, ma'am. Thank you.
Okay. Okay then. I'll see you next week and
Sure,
try to
ma'am.
solve those practice questions. The more you practice, the more familiar you get with the nomenclature. Okay, I will close the meeting.
Sure, ma'am. Okay, ma'am.
Yeah.
Thank you.
Thank you.